Okay. We okay. We're gonna start with the linear relations because there's an activity here that I want to do, and I need class participation to do this. Um, do you know what a line is?
Like a lot, it's a like. You know what I mean?
I'm looking for a definition.
Okay.
Chloe?
It's just.
Okay.
Well, yeah.
What's it made of?
Line. It can be made of like anything, can't it? Yeah.
Mathematically. A mathematical line. What's it made of?
Graphite. Yeah.
Like that? Okay. Did you have an answer? Okay. Okay. It is, yeah.
Straight objects with negligible width. Is that it?
Oh,
Well,
yeah, that is a definition of a line. Like it's not a plane. A plane has length and width, and a line only has length and no width. So you're right there. Um, I obviously didn't ask a very good question because none of those was the answer I was looking for, but that makes it my fault, not yours. So I want to go. There's this program called Desmos, website called Desmos, and it's got some really cool features on it. And one of the things, one of the things that students struggle with lines is understanding that a line is actually made up of an infinite series of points. Okay, that's what a line is. It's just point, 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 point. But they're so close together that you can't distinguish between one point and the next point. Okay. When you have, so I'm gonna start with an equation, and if my equation is, I'm not sure how to do this because I don't want to write on the board. Let me see if I can make this take up less space. And nope, that's not going to work. Okay. Okay, let's just make this super skinny. Okay. If I were to say that x equals 2 plus, or y, sorry, y equals, that's weird. Y, you don't need to write this down. Y equals 2x plus 3. Okay. Um, we're going to do a thing where we have x values and y values. And this equation lets me put in any value for x, and it spits out the corresponding value for y. So if x is 0, what does y equal? Chloe. Try again. Try again. Okay, Gavin. 3. Okay. Chloe, if x is 1, what's y? Now it's 5. Okay, yeah. Because I've got 2 of that 1 plus 3. Okay. If x is 2, what's my y? Yeah. 7. That works. Okay. What if my x is -4? I would, let's make this a little bit bigger here. I can go, you'll see me do this more formally later, but this is 2x plus 3. So this is 2 times -4 plus 3. So that's -8 plus 3, which is -5. Okay. What if my x is 1.3? Can I find a y value for that? What would I do? I would use the equation, right? 2 times 1.3 plus 3, 2.6 plus 3, 5.6, right? Are we good with that? Okay, so what I want to show you now over here, I'm going to plot all of those points. So this lets me put a point 0, 3. Oh, it wants brackets. So there it's graphed 0, 3 for me. And I'm going to graph 1, 5. And it did a blue dot. And I'm going to do 2, 7. And it does a dot. And I'm going to do -4, -5. And it does a dot. And I can do 1.3 and 5.6. And it does a dot. What do you notice about all those dots? Yeah. Oh, that's just, they're all on a straight line, aren't they? They're all on a straight line, and in fact, I'm just finish filling that in. And in fact, if I were to put in here my equation, y equals 2x plus 3, that line goes through all of those points. So I could pick any value, because this is a straight line, and like somebody said, the line goes forever in both directions. It just goes forever and ever and ever. I can pick any value for x, plug it into the equation, it will spit out a y, and it'll be on my line. Okay? Do you believe me?
No.
Give me a number. You just being difficult? Okay, and I can zoom in on here, and I can zoom in forever and ever and ever, and it's still just a series of points. Okay, so we're going to be doing a lot of work with equations of lines, but I want you to remember that any value that you use for x will spit out a y value, which is on that line. Okay, does that make sense? Okay, anything, any number you can think of will be on that line. Okay, okay, all right. Let's go to, that's what I'm going to now, actually. Yeah, and normally I would have done that first, but I wanted to do this when there were students here. Yes, you have a question? Yeah, you don't need to ask, you can just go. Okay, so let's go to the notes for this is unit 3. And we're going to start with, okay, so the unit 3, I don't actually have notes for most of it. Most of it is, I'll do a couple of examples and you will do some more practice, okay? So for this, yeah, we have, this is called a coordinate plane, and this is the x, and up and down is the y. And a friend of mine does it like this. She writes the x like that and the y like that, which I think is a really cool way to remember which one's which. And your ordered pairs, this is what we call an ordered pair, which is 2 numbers. It's always a bracket and your x value and a comma and your y value and a bracket. If you don't have the brackets, it's not an ordered pair and it's wrong. Okay, this is one of those things that matters. So for question 1 here, it says tell what point is located at each ordered pair. So I'm looking for -9, 9. This point in the middle here is called the origin. Maybe I'll label it on this one. This is the origin. And this is at 0, 0. And then it goes in a way that's sensible. Up is increasing numbers, down is negative numbers. To the right is like 1, 2, 3, 4, 5 going up to the right, and going to the left it's negative numbers, just like any number line you've ever seen. Okay? So to find which point is at -9 plus 9, I always start at the origin for doing your coordinate pairs. My first number is my x, so I'm going to go, you know what, I'm going to do a different example. Let's do 2. It's +2 plus 9, so I'm starting at 0. My x is +2, so I'm going to count two lines in the positive x direction, and then I'm going to go plus 9 in the y direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So at that point is a y. Okay? You guys have seen this before, right? You've never seen this? Really? Okay. Not your fault, right? Not your fault. I'm just surprised. That's all. Oh, it's fixable. I just you know what? I kind of have a toolkit that I started and I did on a piece of scrap paper, so I'll get it polished up for sometime this week. Okay. Okay. So that's that section. This next one, it's saying find the find the letter W, which is here, and what are its coordinates? Gavin?
1 and -7.
Right. So to get to here, I have to go 1 on the x direction and -7 in the y. So it's 1, -7. With brackets, it's wrong if you don't have the brackets. It's not an ordered pair if it doesn't have the brackets and the comma. And the last section is plot these on the grid. Okay. And then on the next page, down at the bottom, there's a whole bunch of points for you to plot. It's practice, okay? The most important thing on this page, and I know you will not listen to me because nobody does, but connect your dots as you place them because it's supposed to make a shape. And if you just have a bunch of dots and you don't know what order they go in, you don't know what the shape is. Ask me how I know this. Because that's what I did when I first did this. I just plotted the dots. It's so much easier. I'll join them later. Except no, because I have no idea what order they go in. Okay? So don't do it. Be smart about your lazy. Connect the dots as you go. All right? And then how much of this is what we do today? Graphing a line. So stop playing with what you're playing with or working on what you're working. Yeah, listen to this. Graphing a line. This is probably new for everybody. What does a line of x equals 3 look like? Oh, yeah.
It's a straight line along it's up and down along the 3 line.
Yes, it is. It's a straight line here through 3. Okay? So, a couple of things. You have to either your line go to the end of the graph like that, or use arrows. Okay? Like that. Okay? If I have a line, I'm just going to pretend this one is the same. If I have a line that looks like that, that is incorrect. Okay? It either has to go to the end of the box you're given, or you have arrows, or both is fine, but you have to do one or the other. Okay? And yes, so the reason this goes through here is because at every point, like what's the value, what's the coordinates of that point there? That's 3, 0, right? And this one is 3, 1. And this one up here is 3, 5. So for every point that's on that line, the x value is 3. So it's every point that's that. And like this one right here, this one here, you can't tell, but this is negative 2.83724669. Sorry, it's 3 and then that. Okay? But that still has the x value of 3. So it's on that line. So it's all of those lines. And then finally, you need to identify each line as horizontal or vertical. And this one is vertical. Okay, vertical goes up and down. Horizontal goes straight across like the horizon. Okay, yep. That's right. That's exactly right. Okay. And notice on this one that, like on this grid, each line is 1. It counts 1, 2, 3, 4, 5. On this one, it's counting by 3s. So this one is just like Chloe said, It's Chloe, right? Okay. Um, it goes like that. Okay. If you are doing this on paper, please use a ruler. Okay. I can't. I've tried. A ruler does not work on the tablet. But you guys should be using a ruler. Okay. All right. And is this horizontal or vertical? Does it go like the horizon? Yeah, it's horizontal. Okay. Okay. And that's it for this lesson. So I'm going to just let you practice that, do the practice work. Yeah. Okay. Any questions?